Welcome to Orbit Observer. Settle in wherever you are. Loosen your shoulders, let the pillow take the whole weight of your head, and let your eyes go soft or closed, whichever feels easier tonight. You don't have to follow every word. You don't have to remember anything. There's nothing here that needs solving, nothing here that needs finishing, no place you have to get to by the end. Tonight we're going a very long way from your room, out past everything loud and bright, out to a slow, cold, quiet corner of the solar system, and we're going there gently, at the pace of someone who has all the time in the world and no reason to hurry. So let's take that first breath together, slow and unbothered, and begin. I want to tell you about a moon that can't quite settle down. A very small one. A moon so small that if you set it down on the map of a city, it would barely stretch across it. Because it is only about 2.5 kilometers wide, a fleck of ice and rock about 2.6 kilometers across, which is to say roughly the size of a small town, a modest little island of frozen water drifting in the dark. It has a name that sounds like something out of an old story. Because it is. Its name is Polydeuces. And this little moon, this tiny wanderer, has been given a place of its own out there near the giant ringed planet Saturn, a reserved seat in the sky, a spot that belongs to it and to nothing else. And the gentle, funny, soothing truth about Polydeuces is this. It is almost never actually sitting in that seat. It keeps drifting away from it. And then, ever so slowly, it slides back. That's the whole story, really, a small thing that can't quite stay in its place, that rolls out to one side, pauses, and rolls back through the middle to the other side, and does it again and again, forever, without ever getting tired, without ever getting lost. And if you've ever lain awake at night, unable to find the one position that finally feels right, shifting from your side to your back to your other side, rearranging the pillow, starting over, then maybe you already understand Polydeuces a little. Maybe the two of you have something in common. The difference is that out there, in the deep cold, this endless shifting isn't restless at all. It's the calmest motion in the solar system. It's a body being rocked very slowly by nothing but gravity, out and back, for as long as it has existed. And tonight I'm going to show you exactly how it works, and why it happens, and why this particular little moon is the gentlest, most patient wanderer we know of anywhere. Slowly, with plenty of room to breathe. So there's no rush. Before we go too far, though, let me do the thing I always do at the start. I'd love to know where in the world you're listening from tonight. Whether you're in a city apartment with the traffic finally gone quiet below, or a house at the edge of somewhere dark and rural, or a room I could never picture on the far side of the planet from wherever the next person is. Leave a little note down in the comments and tell me where you are and what the night is like there. I read them. It's one of my favourite small pleasures, to sit and picture all the different rooms this same slow voice is drifting into, all the different windows, all the different weather. And if you're new here, if this is your first night with me, you can settle in and subscribe, and there'll always be another one of these waiting for you, another slow journey out into something old and strange and quiet, for whenever you need it. That's all. That's the only thing I'll ask of you tonight. Now let the day go and come out to Saturn with me. Let me set the scene properly, because the scene is half of the comfort. Picture Saturn. Not the whole busy picture of it, not the rings blazing or the storms turning, just the plain enormous fact of it, a pale golden globe hanging in the black, so large that everything near it is held in its grip. And circling that giant, at their measured distances, are its moons, dozens upon dozens of them, some large and round and famous, some tiny and lumpen and nameless. each one keeping to its own lane, its own track around the planet, like runners on a vast circular course who never crowd each other, never collide, each one pacing out its own steady loop in the cold. Our story lives in one of those lanes, not the biggest one, not the brightest, just one particular track around Saturn and the two little moons that share it. The first of those two is called Dione. Dione is the settled one, the anchor, the one everything else in this story is arranged around, so let's get to know her first. Dione is a proper moon, round and solid and bright with ice, and she rides her lane around Saturn at a distance of about 377,000 kilometers from the planet. 377,000. 400 kilometers, give or take, out from Saturn's center. That's a number too big to really feel, so let it just wash over you as far, very far, a comfortable, enormous distance, the kind of gap you could fall asleep somewhere inside of. And Dione takes her time going around. One full loop of Saturn, one complete lap of that great circular track, takes her about 2 3/4 days, about 2.74 days to be a little more exact, which is to say a little under 3 of our days, for one trip all the way around the ringed planet and back to where she started. Slow, steady, the same loop, over and over, for billions of years, unhurried, unbothered, keeping perfect time. And here is the first quietly lovely fact, the one everything else grows out of. Polydeuces, our tiny wanderer, our little 2.5-kilometer fleck, rides the exact same lane. Not a nearby lane, not a slightly higher or slightly lower track. The same one. Polydeuces travels around Saturn on essentially the same path as Dione, at essentially the same distance from the planet, taking essentially the same amount of time to go around. That same slow 2 3/4 day loop. Two moons, one enormous circular track around a giant planet, pacing each other through the dark. They share the road. That's what makes this whole thing possible, and that's the first thing to hold on to as you drift, the picture of two companions on one long, slow, curving path, keeping the same time, one large and steady, one small and wandering, going around and around together. Now they don't ride side by side. That's the part that makes this special, and it's worth going slowly here, because this is the heart of where Polydeuces lives. If two moons are on the same track, going around at the same speed, you might imagine they'd have to be right next to each other. Or else one would slowly pull ahead and the other fall behind until they were spread out anywhere and everywhere. But that's not what happens. Polydeuces doesn't ride beside Dione, and it doesn't wander freely all around the loop either. Instead, it keeps its distance, a very particular distance, holding a certain way back behind Dione along the track, trailing her by a specific angle, as though the two of them were tied together by an invisible thread of exactly the right length. And that angle, that gap, that place where Polydeuces keeps itself, is 60 degrees behind Dione. 60 degrees around the loop. Trailing her, following her, 60 degrees back along the shared path, like a slow-moving second runner who never catches up and never falls away. Always the same measured stretch of the track behind the first. 60 degrees. Hold that gently in mind, because it's going to matter, and it's one of the most beautiful little facts in all of this. But for now, you don't need to know why it's 60. For now, just picture it. The great circle of the track around Saturn. Dione moving along it, bright and round, and a long, long way behind her, 60 degrees back around that curve, the little speck of Polydeuces, following faithfully, never gaining, never losing, keeping its distance in the dark. That spot, 60 degrees behind Dione, is the reserved seat I mentioned. It has a proper name. It's called a Lagrange point, and the one behind Dione, the trailing one, is labelled L5. We'll come to what a Lagrange point really is, slowly, over the course of tonight, because it's the whole secret of why Polydeuces behaves the way it does. But for now, just let the idea sit softly. There are special spots along a shared orbit, invisible spots, marked by nothing, no buoy, no sign, just points in empty space, where a small body can settle in and keep pace with the bigger ones around it. And the one 60 degrees behind Dione, the trailing sweet spot, the point called L5, is the seat that belongs to Polydeuces. That's its address. That's its assigned place in the whole vast machinery of Saturn's moons. 60 degrees behind Dione, at the trailing Lagrange point. That's home. And here's the gentle joke of it, the thing that makes this little moon so endearing, the thing this whole night is really about. Polydeuces is almost never actually there. It has this perfect reserved seat, this exact spot that's meant to be its own, and instead of settling into it and staying put, it drifts. It wanders off to one side of the seat, out along the track, easing away from its assigned place, farther and farther, slowing as it goes. And then it pauses, hangs there for a while at the far edge of its wandering, and begins the long, slow return, sliding back toward the seat, through it and out the other side. And then it does the whole thing again. It never really arrives, it never really sits down. It spends nearly all of its existence either drifting away from its spot or sliding back toward it, always in motion, always in transit, forever leaving and returning around a place it almost never occupies. A moon that can't settle into its own chair. I told you the two of you might have something in common. But let me be very clear about one thing, because it matters for how easy you feel as you listen. This wandering is not a problem. Nothing is wrong. Polydeuces isn't lost, isn't falling, isn't in any danger, isn't drifting off into the dark to be forgotten. The wandering is simply what this little moon does. The way a boat tied in a gentle harbour eases out to the end of its line and swings slowly back, the way a swing at the bottom of its arc will always roll back through the middle. It's held, it's safe. Something out there, something invisible and patient, always pulls it home. And we'll get to exactly what that something is. And I think you'll find it one of the most reassuring facts in the whole sky. But hold this now, as a kind of promise for the night. However far Polydeuces drifts from its seat, it always comes back. It cannot help but come back. The same gentle physics that lets it wander so far is the very thing that will never let it get away. Out and back. Out and back. Held the whole time. So how did we ever find such a thing? A speck of ice, 2.5 kilometers across, 60 degrees behind a moon, hundreds of thousands of kilometers, out from a planet that is itself more than 1 billion kilometers away from us. How did anyone ever notice it at all? For that, we have to bring in the other main character of tonight's story, and it's a machine, a spacecraft, one of the most beloved robotic explorers we ever sent anywhere. Its name was Cassini. Cassini was a NASA orbiter built to travel all the way out to Saturn and stay there, to loop around the ringed planet for years and study it up close. It was a long, patient mission, the kind that takes a big slice of a human lifetime. Cassini launched from Earth back in 1997, and then it spent years crossing the enormous gulf of the solar system, coasting out through the dark, past the sun's inner warmth and into the cold. Until at last, in the middle of 2004, it arrived at Saturn and slipped into orbit around the giant planet. Think about that patience for a moment. As your breathing slows, a machine sent off in 1997, quietly falling through space year after year, not reaching its destination until 2004, and then, having finally arrived, beginning the real work of looking closely at everything Saturn had to show. And it was in that very first stretch of looking, in that same arrival year of 2004, that Cassini started finding things nobody had seen before. New moons, small ones, tiny companions of Saturn that had been too little and too faint to spot from all the way back at Earth, hidden in the glare of the planet and the rings, waiting out there in the dark for a camera to come close enough. Cassini carried an imaging team, a group of people whose task was to study the pictures the spacecraft sent home, frame after frame of Saturn and its moons and its rings, and to watch for anything new, anything that moved against the stars, anything nobody had catalogued yet. And on the 24th of October, in the year 2004, in images taken by Cassini during that first year at Saturn, the imaging team found our little wanderer, a faint moving point of light tucked into Dione's orbit, riding that shared lane 60 degrees behind the larger moon. 2.5 kilometers of ice revealed at last. The 24th of October, 2004, that's the birthday of our knowledge of it. The day this small, patient, restless thing stopped being invisible and became something people knew about. At first it didn't even have its lovely mythological name. When something new is spotted out there, before it's properly named, it gets a kind of placeholder tag, a plain scientific label that records when and where it was found. And so at first, Polydeuces was simply called S2004 S5. It's a modest little string of characters, but there's a quiet poetry to it once you unpack it, and unpacking it is exactly the kind of slow, low-stakes thing that's easy to drift off inside of, so let me do it gently. The S at the front just means it's a satellite, a moon, something orbiting. The 2004 is the year it was found, that same arrival year. That busy first season of Cassini's discoveries. Then another S, this one for Saturn, the planet it belongs to. And finally the number 5, because it was the 5th new little satellite of Saturn to be catalogued that year. The 5th. Which tells you something all on its own, doesn't it? That in a single year, a single spacecraft, freshly arrived, turned up new moon after new moon after new moon. And our Polydeuces was simply the 5th in that season's quiet parade of discoveries, one more tiny companion among the many that Saturn had been hiding all along. S2004 S5. And only later did it receive its real name, the name we'll use for the rest of the night. Polydeuces, it was given a proper title in the great catalogue of Saturn's moons as well, a formal designation. Saturn the 34th, Saturn exexive, taking its place in the long-numbered line of the ringed planets family. But Polydeuces is the name that suits it, and Polydeuces is what we'll call it. We'll come later on to who Polydeuces was in the old stories, and why the name fits a moon that shares another moon's path so beautifully. For now it's enough to know that the Wanderer has a name, and a discovery day, and a discoverer, a spacecraft called Cassini that crossed the dark for 7 years to find a fleck of ice 2.5 kilometers wide, quietly following Dione around the giant planet. Now let me give you the image I want you to carry down into sleep, the one at the very center of everything. The picture that makes all of this make sense in the body before it makes sense in the mind. Because you don't have to understand the mathematics to feel this, you just have to picture a marble in a bowl. Imagine a bowl, A wide, shallow, smooth bowl, the kind with gently curving sides that rise up slowly from a low point in the middle, no steep walls, nothing sharp, just a soft, broad hollow. And imagine you set a marble down near the middle of that bowl, but not exactly at the center. You give it the tiniest push off to one side. What does the marble do? It rolls. It rolls up the gentle slope of the bowl, climbing the curve, slowing as it goes, because the higher it climbs, the more the slope resists it, until finally, near the top of its little journey, it slows all the way to a stop. Hangs there for just a moment, poised at the far edge of its roll. And then it comes back. It rolls back down the curve it just climbed, gathering the smallest bit of speed as it nears the bottom, passing through the low center of the bowl, and carrying on up the other side, climbing the opposite slope now, slowing again, stopping again, and turning around again, out and back. Up one side, down through the middle, up the other side, and back. If the bowl were perfectly smooth, with nothing to slow the marble down, no friction to steal its motion, it would do this forever. Rolling out, pausing, rolling back, crossing the center, rolling out the other way, pausing, coming back, over and over and over, an endless gentle rocking around the lowest point of the bowl. That is Polydeuces. That is exactly, precisely what our little moon is doing. The bowl is that reserved seat, that Lagrange point, that sweet spot 60 degrees behind Dione. It isn't a bowl made of anything you could touch, it's a bowl made of gravity. A hollow in the invisible landscape of forces out there around Saturn, a low place where a small body naturally wants to rest. And Polydeuces is the marble. Set rolling long ago, slightly off from the exact bottom of that gravitational bowl, it climbs out toward one side, drifting away from its seat, slowing as it goes, until it pauses at the far edge of its wandering. And then it rolls back, sliding down toward the seat, passing through it, out the other side, climbing again, pausing again, returning again. Out and back, away from its place, and home again. Forever, a marble in a shallow, almost frictionless bowl of gravity, rocking slowly around a spot it never quite comes to rest in. Let that image settle. A marble in a bowl. You've watched a marble roll in a bowl. You know in your hands and your eyes exactly what that motion looks like, that soft climbing and slowing and turning and returning. And now you know that a real moon out at Saturn is doing that very thing right now, tonight, while you lie here, rolling slowly out and slowly back around its invisible sweet spot in the dark. It was doing it before you were born. It'll be doing it long after this night is forgotten. Out and back. Out and back. And here's a detail that makes the marble in a bowl even truer to what's really happening, and even calmer, so let me linger on it. The bowl is shallow, that's important. It's not a steep, narrow pit with high walls that would snap the marble sharply back and forth. It's a broad, gentle, dish-shaped hollow, sloping up so softly that the marble takes a long, unhurried time to climb even a little way out of it, and just as long to drift back down. That shallowness is why the whole motion is so slow, so soft, so utterly unhurried. If the gravitational well behind Dione were a deep, sharp pit, Polydeuces might jitter back and forth quickly, nervously, restlessly. But it isn't. It's a wide, gentle valley, and so the moon's rocking is wide and gentle too. A long, slow, sleepy sway, the very opposite of restless, a body taking the most leisurely possible amount of time to lean out to one side and ease itself back. Everything about this motion is slow. That's the gift of it. That's why it's the perfect thing to fall asleep to. Just how slow I'll save for a little later, because it deserves its own quiet moment, and because the number is so lovely and so large that it's worth arriving at gently rather than rushing to. But let me plant the seed now, so you have something soft to drift toward. One full sway of Polydeuces, one complete roll out to the far side and all the way back, is not a matter of minutes or hours or even days. It takes years. A single out and back of this marble in its bowl of gravity is measured in years. So the moon we're watching keeps a slower time than almost anything you could name, a rhythm so unhurried that a single breath of it, one drift out and one slide back, would carry you through more than 2 turns of the seasons here on Earth. Hold that as a promise, and we'll come back to the exact figure when the time is right. For now, come back with me to where it sits, and let's just rest there a while, because the geography of this is soothing all on its own, and there's no reason to leave it. 60 degrees behind Dione. That's the address. Let me build the whole picture around you one more time, slowly, layer by layer, so it's fully there in the dark behind your eyes. Start with Saturn, the giant, the golden globe, huge and calm at the center of everything. Around it, out at that distance of about 377,000 kilometers, runs Dione's track, her great circular lane through space. On that lane, Dione herself, bright and round and steady, pacing out her slow loop. One full trip around Saturn every 2 3/4 days, unhurried, eternal. Now follow the lane backward from Dione, back along the curve, back around the loop, 60 degrees of the way around, and there, in that patch of apparently empty space, is the seat. The trailing Lagrange point, the sweet spot. And in that neighborhood, drifting slowly out toward one side of it and slowly back toward the other, is our little moon, our 2.5-kilometer fleck of ice, keeping its distant appointment, following Dione at its careful 60 degrees, forever a little ahead of its seat or a little behind it, forever leaving and returning, but never ever falling away from that shared lane, never losing Dione, never getting lost. 2 moons, 1 road. A bright steady leader and a tiny restless follower, tied together across the dark by the invisible geometry of that sweet spot. And the whole arrangement turning, slowly, grandly, around the giant planet, once every 2 3/4 days, while the small one rocks out and back on its own far slower rhythm within the loop, a slow sway nested inside a slow orbit, like a sleeper turning gently in a bed that is itself being carried through the night. There's something so restful about that, isn't there? The idea that even out there, in the enormous cold, in a place with no air and no sound and almost no light, so far from anything warm, there is this small patient motion going on, this endless soft rocking, held safe by nothing more than the shape of gravity itself, a tiny thing that cannot settle, that keeps drifting from its place, and yet is never in the slightest danger. Because the very reason it drifts is the same reason it always comes home. There's no struggle in it, there's no anxiety in it, there's just the motion, out and back, as reliable as a tide, as gentle as breathing, going on, whether anyone is watching or not. And tonight, for a little while, someone is watching. We are. You and I, and the little moon, and the slow lane around Saturn, and the shallow bowl of gravity 60 degrees behind Dione. That's the whole company we need. So let's stay here a moment longer before we go deeper, and just let the picture rock you a little. Feel how far away it all is. Feel how slow it all moves. Feel how nothing out there is in any hurry, least of all our small wandering moon, easing out toward one edge of its invisible seat right now. At this very moment, so slowly you could never see it move. Drifting away from the spot that belongs to it with the patience of something that has been doing exactly this for longer than there have been people to give it a name. It doesn't know you're listening. It doesn't know anything at all. It simply rolls out and back in its shallow bowl, keeping the slowest time in the sky. And in a little while I'll tell you the proper name for that rolling, the word the scientists use for it, and I'll show you just how far Polydeuces strays, and how long one full sway really takes, that lovely, slow number I've been promising you. I'll introduce you to the moon on the other side of Dione, the one that keeps its seat 60 degrees ahead, where Polydeuces keeps its seat 60 degrees behind, so that Dione travels through the dark with a companion on either side, one leading, one trailing, a small, quiet escort through the years. And I'll show you why, of all the planets we know, it is only Saturn that gathers its moons together in this particular way, and why this one little speck of all the wandering companions in the whole solar system holds a record that no larger, grander body has ever taken from it. But none of that has to happen yet. There's no need to reach for any of it. It'll come, in its own slow time, the way the moon comes back to its seat, without hurry, without effort, arriving simply because that's what it always does. For now, all you have to do is rest here, 60 degrees behind Dione, out where the light is faint and the cold is deep, and the little marble rolls forever in its shallow bowl of gravity. Let your breathing slow to match it. Out and back, away and home, drifting from the place that's yours and being gently pulled toward it again, over and over, held the whole time, safe the whole time, never once in danger of being lost. Stay with me. We've only just arrived, and the night is long, and there's nowhere at all we have to be. So then, the word. The scientists who study the motion of Polydeuces, who have mapped its wandering across years of Cassini data, who have run the equations forward and backward to understand why it swings so far and what keeps it from flying loose, those scientists use a word that is older than space travel, older than telescopes, older almost than any precise scientific vocabulary at all. It comes from Latin. It means, at its root, to weigh from one side to the other, the way a balanced scale tips and tips back, searching for the middle point, never quite resting. The word is libration. And when you hear it said aloud for the first time in this context, in reference to a moon that spends its whole existence drifting out from its seat and sliding gently home again, it sounds almost too right. Too perfectly chosen. Libration, the rocking of something that is looking for its balance, the oscillation of a body held in the center of a gentle pull, not locked into stillness, but swinging, always swinging, out and back through the point that holds it. That is what Polydeuces does. That is what its motion is called. And the reason the word feels so comfortable tonight, so well suited to the mood of this particular hour, is that libration is precisely the kind of motion that invites the body to follow along. Not a sharp vibration, not a sudden jolt or a dramatic plunge, just the slow, continuous, pendulum-like passage away from a center and the equally slow, inevitable passage back toward it. A rocking, a breathing, a sway so gradual and so patient that you could watch it for years and still find it soothing. Let me try to make it exact for you, to give it the specific shape it actually has, because the real numbers are what make it extraordinary. Polydeuces does not sit at its Lagrange point and vibrate slightly, the way you might imagine a tiny tremor barely visible in a long-exposure photograph. It leaves. It actually leaves, meaningfully and measurably, swinging out from its assigned position by something in the range of 30 degrees or more in either direction, ahead of the point and behind it, forward and backward along the shared curve of Dione's orbit, so that at its farthest departure it is more than a third of the way around a full arc from where the physics says it belongs. Think of a pendulum clock, and imagine that instead of the pendulum swinging a few inches on either side of center, it swings halfway across the room. That is closer to the scale of what Polydeuces does. The motion is real, and it is large, not some subtle wobble that only a computer would notice, but a genuine and extensive wandering that carries it through an enormous portion of the sky, as seen from Saturn or from Dione herself. 30 degrees is not nothing. 30 degrees is the difference between one point in space and a place far enough away that the stars behind you would shift noticeably if you could stand on Polydeuces and look back at the geometry. 30 degrees, give or take, on each side of the point it never quite inhabits, out to one side, back through the middle, out to the other, back through the middle, out and back. The same motion, repeated, unhurried, forever, and how long does one full passage take? One complete journey from one extreme through the center to the other extreme and all the way back to the starting position, a single breath of that great slow rocking. The answer is where the numbers become genuinely beautiful, genuinely fitted to the purpose of a night like this one. It takes Polydeuces approximately 790.9 days to complete a single libration cycle. 790 days. That is, at the rough approximation your mind can hold without effort, 2 years, and then a little more, 2 turns of the Earth around the Sun, plus a few additional weeks, plus some days beyond that, for one full swing of this tiny pendulum in the dark. More than 2 years for a single back and forth. A child born the day Polydeuces reaches one extreme of its wandering would be walking and talking by the time it returned to that same position. A garden planted when the moon is farthest from its seat would be harvested and then left through winter and planted again and harvested again before the cycle completed itself. 790 days, each of them spent somewhere in the arc of that slow and patient oscillation, never hurrying, never arriving cleanly, simply and continuously on its way somewhere along the path between departure and return. That number, 799 days, is the heartbeat of Polydeuces, not the fast beat of its orbital period. The quick 2 3/4 days it takes to travel all the way around Saturn alongside Dione, but this deeper, slower rhythm underneath, the one that governs not how fast it circles, but where in its great arc it sits at any given moment. Every time it completes one orbit of Saturn, every 2.74 days, Polydeuces has advanced a little further through its libration. A small nudge along the pendulum's path, another fraction of a degree toward the far edge of its swing, or another fraction of a degree back toward the center. Hundreds of those orbital laps laid end to end over hundreds of days before the libration completes itself and begins again. It is like watching a second hand sweep around a clock face while knowing that somewhere a much slower hand, nearly invisible in its motion, is moving through a cycle measured in years rather than seconds. Both are real. Both are happening simultaneously. The quick orbit and the slow libration stacked on top of each other, the moon tracing a long, intricate path through space that is the product of both at once, a looping, curving, gently wandering track that never quite repeats itself the same way twice. Now, I want to tell you about the companion, the other one. Because Polydeuces does not keep its vigil behind Dione in complete solitude. 60 degrees ahead of Dione, not behind, but ahead, out in the space that Dione is approaching, rather than the space it has already passed through, there is another moon. A small one, though larger than Polydeuces. Its name is Helene. And Helene has been there, at Dione's leading side, for a very long time. It was found much earlier than Polydeuces, discovered in 1980. More than 2 decades before Cassini arrived at Saturn and found the tiny wanderer on the trailing side. Helene is at what the dynamicists call L4, the leading Lagrange point, the 4th of the 5 equilibrium positions in the Saturn-Dione system. Where Polydeuces keeps its restless seat at L5, the trailing point 60 degrees behind, Helene sits ahead 60 degrees in front of Dione, riding the crest of the gravitational wave that Dione pushes ahead of itself as it travels. Helene and Polydeuces 60 degrees forward and 60 degrees back, and between them, never looking sideways, keeping to the middle lane, always and only at the centre, Dione itself, the moon that both of them accompany, the body around whose orbit this whole intricate arrangement is organized. So Dione does not travel alone. It has not travelled alone for as long as we have known to look. It moves through the dark with an escort, 1 moon ahead and 1 moon behind, both of them holding their positions in a loose and patient formation that covers a full 1/6 of the orbital ring, 60 degrees on one side, 60 on the other, with Dione at the centre of the arrangement. From very far away, from a distance so great that all 3 moons were just 3 points of light in the outer solar system, you might not know that any relationship connected them. They would appear to be 3 separate moons in approximately the same part of Saturn's satellite system, not obviously bound together, not obviously part of a single coherent structure. But the relationship is there, encoded in the orbital numbers, visible in the geometry once you know how to read it. Dione is accompanied, has always been accompanied, or at least as long as the companions have been in their current positions, which is a span of time we do not know exactly, but which may be very, very long indeed. Perhaps as long as the solar system itself has been arranging things into their present configurations. And it is worth pausing on the symmetry of it, because there is something in that arrangement that the mind can hold comfortably at this hour. Something that feels almost intentional in its tidiness. 2 flanking companions, equally spaced, 1 ahead and 1 behind, surrounding a central moon that needs no escort but carries them anyway. It is a small, self-contained system within a system, a miniature formation tucked inside Saturn's vast retinue of moons, ordered in a way that the math of gravity has quietly organized over ages. Helene at L4, Polydeuces at L5, Dione in the middle. The geometry of it is not complicated, and its neatness is not accidental. It is a consequence of the same physical rules that place Lagrange points where they are, that stabilize the positions 60 degrees off, that allow a body of nearly any mass to maintain its station in those positions as long as the larger masses involved are sufficiently dominant. And in the case of Saturn and Dione, that condition is satisfied so completely, so overwhelmingly, that the stability of those flanking seats has held for what may be timescales we cannot easily picture. Helene and Polydeuces, waiting on either side, companions to a moon that outweighs them both by margins that dwarf any comparison we might try to make. Helene holds its place with more restraint than Polydeuces. It librates, too. Almost nothing at an exact Lagrange point is ever perfectly still, but its wandering is much more modest, more contained, the pendulum swinging only a little before the gentle well of the Lagrange point draws it back. Polydeuces is the one that swings wide, that departs dramatically. That traces the great looping tadpole path through space and takes nearly 791 days to finish one loop. Between the two of them, you can see the full range of what Trojan libration can look like, the quiet, nearly settled moon on one side, and the great restless wanderer on the other, both kept in place by the same gravitational arrangement, both faithful to the same central moon. But one of them barely moving, and the other rolling back and forth across nearly a third of the sky above Saturn. That contrast is itself worth a moment of attention, because it hints at something the dynamics of the solar system finds endlessly productive, which is that the same set of rules, operating on bodies with different starting conditions or different masses or different histories, can produce outcomes that look nothing like each other. Helene found a quiet accommodation with its seat. Polydeuces found the most extreme accommodation that any Trojan companion has ever found anywhere in the solar system. Both arrangements are stable. Both are permitted by the same underlying physics. One is stillness, one is the widest wandering. And yet both, in their own way, are held. But Dione is not the only moon in Saturn's family that has this distinction. There is another pair. Tethys, another of Saturn's larger, older moons, orbiting closer in to Saturn than Dione does, a world of ice and deep canyons and ancient impact scars. Tethys also keeps companions at its own Lagrange points. Two of them. Their names are Telesto and Calypso. Telesto at the leading point, L4, riding 60 degrees ahead of Tethys, the way Helene rides 60 degrees ahead of Dione. Calypso at the trailing point, L5, riding 60 degrees behind Tethys, the way Polydeuces rides 60 degrees behind Dione. The arrangement is the same. The geometry is the same. The physics that permits it is the same. And the result, in both cases, is a central moon moving through Saturn's system with a small pair of companions attending it, one before and one after, as if the solar system had decided that certain moons deserved escorts and arranged the mathematics accordingly. There is something remarkable in this, and I want to let it settle in gently rather than rushing past it. Of all the planets we know, every world in our solar system that carries moons of its own, all the planets from Mercury outward to Neptune, Saturn is the only one that hosts this particular arrangement. Trojan moons. Moons that ride their neighbours' Lagrange points, that share a larger moon's orbital track and keep their stations 60 degrees away. We have not found Trojan moons at Jupiter, though Jupiter hosts tens of thousands of Trojan asteroids at its own Lagrange points along its path around the Sun, little rocky bodies that have been riding Jupiter's L4 and L5 regions for billions of years. We have not found them at Uranus, or Neptune, or anywhere else in the catalogue of known satellites. Only Saturn. Only here, in this system of rings and ice and ancient arrangements, have moons themselves accumulated Trojan companions. Two pairs of them, no less. Dione with Helene and Polydeuces, Tethys with Telesto and Calypso. 4 moons in Trojan relationships, organized into 2 matching pairs, surrounding 2 central moons in the same elegant bilateral formation. We do not know with certainty why Saturn is the one planet to host this. There are ideas, careful dynamical reasons, having to do with the masses of Saturn's moons relative to Saturn itself, and with the long-term stability conditions that allow Trojan relationships to persist rather than being disrupted by close gravitational interactions with other passing bodies. Saturn's middle-sized moons, the ones that might serve as Trojan hosts, sit in a region of the satellite system where the conditions for Lagrange point stability happen to be particularly favorable, where the mass ratios work out, where the orbits are spaced far enough apart that one moon's gravity does not constantly disturb another's Trojan companions into instability. And perhaps there is also something about the deep history of Saturn's satellite system, the way its moons formed or were captured or rearranged themselves over the first billions of years of the solar system, that happened to deposit small bodies in the right positions for Trojan orbits to take hold and last. We do not know the full story, but the result of whatever that story was is that Saturn, of all the worlds we know, keeps these companions. Saturn is the Trojan moon capital of the solar system, the only place where moons escort other moons in the long patient way that Helene and Polydeuces escort Dione, that Telesto and Calypso escort Tethys, riding ahead and behind, faithful in their geometry, held by the same invisible math that holds everything else in place. And of the 4 Trojan moons, Helene, Polydeuces, Telesto, Calypso, one of them has claimed a distinction that belongs to no other co-orbital body we have found anywhere. Not just among the Trojan moons of Saturn, not just among the Trojan companions of any moon, among every Trojan body known in every part of the solar system, from Jupiter's 50,000-strong swarms to the scattered few we have catalogued at Mars and Neptune and elsewhere, among all of them, Polydeuces has the widest libration. This 2.6-kilometer speck, this faint point of light in Cassini's cameras, this wanderer that keeps a seat it never actually occupies, swings farther from its Lagrange point than anything else we have ever seen or measured. And it has done this, presumably, for a very long time. Not because it is particularly strong, or particularly energetic, or particularly determined in some quality we might admire, but because it is particularly light, and because the bowl it rolls in is particularly shallow, and because the faint tugs that stir it have never been quite in the right direction at the right moment to settle it into a smaller sway. It rolls wide because it can, because nothing has stopped it, because the physics of the situation permits a wandering of that scale, and so a wandering of that scale is what it performs. The scientists call the shape of Polydeuces' path a tadpole orbit. It is a technical term, but the image it calls up is a useful one. You can picture the path the moon traces, not as a simple back and forth along a straight line, but as a looping, curved, slightly bulging path that wraps around the Lagrange point at one end and stretches out in a long, tapering arc on either side, the way the body of a tadpole tapers from its round head toward its trailing tail. The Lagrange point itself sits roughly in the middle of the bulge, the head of the tadpole, and the path of Polydeuces loops around it and extends outward to either side, marking the territory that the moon patrols over its nearly 791-day cycle. It is not a straight oscillation. The orbital mechanics of a moon moving in 2 dimensions around a planet while simultaneously librating around a Lagrange point produce this particular curved shape, and the tadpole label captures something essential about it. The roundness at one end where the motion doubles back on itself, the long tapering at the other where the moon slides farthest out. The whole path suggesting something organic and gently purposeful, like the motion of a small creature navigating its own small world. There is another shape that a co-orbital body's path can take, and I want to mention it briefly, not because Polydeuces is in danger of it, but because it exists, because it is possible in principle, and because understanding that it exists makes the tadpole path feel a little more specific, a little more particular to Polydeuces' situation. If the libration amplitude were to grow, if something were to nudge Polydeuces harder and harder in the same direction, adding energy to its oscillation over many cycles, there is a threshold beyond which the tadpole orbit would become something different. The path would stretch and widen until it no longer stayed near a single Lagrange point, but instead looped entirely around both, passing through the region ahead of Dione and the region behind Dione in a single enormous oval. This is called a horseshoe orbit, named for the shape the path traces when drawn in the reference frame that rotates with Dione. A horseshoe orbit body does not stay near L5 or L4, but circulates between them, spending time on both the leading and the trailing sides of its companion moon, switching endlessly from one to the other over very long timescales. It is a different kind of co-orbital relationship, and it exists in Saturn's system, but not at Dione. Polydeuces is not a horseshoe moon. It stays in its tadpole, looping around L5, its assigned side, swinging very wide, but never quite crossing the threshold into the larger different motion. The horseshoe moons of Saturn are Janus and Epimetheus, and they perform their exchange in a way that is entirely unlike what Polydeuces does, even though both kinds of motion are called co-orbital, and both involve moons sharing a region of orbital space. Janus and Epimetheus actually swap orbits. One moves slightly closer to Saturn, the other moves slightly farther out. And every 4 years or so they pass close enough to each other that their gravity redirects them, the inner one moving out and the outer one moving in, trading positions in a choreography that has been ongoing for longer than we have had eyes good enough to see it. That exchange is a different animal altogether from the gentle libration of Polydeuces, which never trades places with anything, which never changes its relationship to L5 or to Dione in that fundamental way, which simply rolls back and forth in its tadpole path and comes back to the middle every time. The distinction matters, and I mention Janus and Epimetheus here only to draw the line clearly between what they do and what Polydeuces does, so that when you carry the image of the tiny wandering speck with you through the rest of this night, you know what kind of motion it is: the libration, the slow rocking, the pendulum in the shallow bowl. And do not confuse it with anything sharper or more dramatic than that, because the motion of Polydeuces is not dramatic. That is the whole point of it in a way. It is as undramatic as motion can be while still being motion. It has been swinging out and sliding back across the trailing region of Dione's orbit, tracing that same tadpole path, completing that same 790. 9-day cycle, probably for millions and millions of years, without any visible sign of urgency or consequence. No collision. No disruption, no sudden change of course, just the sway, unhurried and continuous, the moon never arriving and never truly departing. Always somewhere in the long arc between one extreme and the other, always in motion, always held. The libration is what it does. The libration is, in some deep sense, what it is. A body defined not by where it sits, but by the path it keeps, not by its position at any given moment, but by the patient rhythm of its departure and return. And here, in this late and quiet hour, I find that rhythm easier to picture if I let it move slowly enough. 790 days for one complete sway. That means that on any given night, tonight, this night, with all its particular sounds and silences, and the specific quality of darkness outside your window, Polydeuces is somewhere in its arc. Not at the Lagrange point, almost certainly. Almost never at the Lagrange point. Somewhere along the path. Sliding, perhaps, toward the far end of its swing, the place where the gentle pull of the Lagrange well begins to slow it and draw it back. Or perhaps already on the return, drifting slowly in through the middle of its tadpole, crossing the imaginary line that marks L5's position and continuing past it to the other side. Or at the far extent of the other side, slowing again, pausing at the end of its reach, and beginning to come home. Wherever it is in that cycle tonight, it is in exactly the right place for where it is in the cycle. There is no wrong position in a libration. There is no moment at which Polydeuces is somewhere it should not be. The whole arc is its territory. And every point along the arc is, in its own way, where the moon belongs. That is the word, and that is the motion. Libration, a 30-degree or more oscillation in each direction. A 790.9-day period for one full breath. A tadpole path wrapped around the trailing Lagrange point of Dione, kept in place by the same gravitational geometry that gives Helene its seat 60 degrees ahead, that gives Telesto and Calypso their seats around Tethys, that makes Saturn the only planet in the solar system with this arrangement. Moons escorting moons, companions riding companions. The whole elaborate patient formation held together by numbers that have been true since long before anyone was here to write them down. The formation holds. The Lagrange points hold. The slow rhythm holds. Polydeuces swings out and slides back, and swings out again, tracing the same long looping path it has always traced, and Helene rides ahead of Dione in its quieter, steadier fashion. And Dione itself moves through the middle of its orbit around Saturn, with both of them faithfully attending, one before and one behind, 60 degrees on each side, and somewhere farther in, Tethys makes its own journey with Telesto and Calypso beside it, the same arrangement at a different address, the same physics expressing itself twice over in the same planetary system. All of it moving. All of it held. The whole ensemble of companions and hosts and Trojan moons drifting through Saturn's system in the long, slow order that gravity has spent billions of years arranging. You do not have to hold all of that at once. Let most of it recede. Let the formation simplify to just the one that matters tonight. That faint speck behind Dione, rolling in its shallow bowl, making its slow and patient way through 790 days of gentle wandering. That is the one. That is the one that holds the record, the one that swings the widest, the one that can never quite settle into its own seat, and is never, for even a moment, in any danger because of it. That is Polydeuces. And it is still out there tonight, exactly where the math says it should be, which is somewhere in the arc, somewhere in the middle of its great slow sway, drifting outward or sliding home, or hovering at the edge of its reach before the gentle well turns it around. Still moving, still held, and still, in its own way, at rest, because the motion itself is the rest, when the motion is this slow, this patient, this endlessly repeated in the cold and the quiet and the faint gold of distant Saturn's light. We are still early in this. There is more to understand about why the bowl is shaped the way it is, about why Polydeuces in particular swings so much wider than any other Trojan companion, about the distances involved as it liberates, The way the gap between Polydeuces and Dione opens and closes like a slow tide over the course of each 790-day cycle. From something near to something very far and back again. There is the question of what originally set it rolling, what gave it the push that sent it wandering across such a wide arc rather than settling into a quieter oscillation near the center of its bowl. There is the question of Saturn's uniqueness, the deeper reason why this arrangement exists here and only here. And there is something to say about what it means that the tiny body with the lightest mass and the smallest presence is the one that holds the record for the widest sway. The insight that is counterintuitive at first and then, once you hear it explained, seems almost inevitable. All of that is still ahead. For now, let the libration be the thing. Let the word settle into your breathing. Libration, out and back. Away and home. The same arc, repeated, without end, in the cold and the dark and the faint and steady company of all the other moons keeping their own patient rhythms around the planet that holds them all. So let us slow down even further and look at the shape of the bowl itself. Because this is where the explanation lives. Not in some special property of Polydeuces that you could measure if you held it in your hand, not in its color or its texture or the particular angle of one of its dents. The explanation lives in the geometry of the space it inhabits, in the invisible architecture of gravitational balance that the solar system arranges around itself wherever two bodies of very different size share a path. And the strange, quiet, almost elegant thing about that architecture is that it has a shape. A literal, describable, mathematical shape. And that shape, once you have it in your mind, makes everything else about Polydeuces make sense in the way that a key makes sense when you see the lock it fits. Begin with two bodies, Saturn, enormous, the planet we have been circling in this conversation as surely as Polydeuces circles it in the dark, a world so large that roughly 700 Earths could fit inside its volume. A planet of such mass that it warps the gravitational field of the entire surrounding region into something complicated and layered and full of niches. And Dione, so much smaller, orbiting Saturn at a distance of about 377,400 kilometers, a moon that takes only about 2 3/4 days to complete one full lap, moving with a patient regularity that has not changed in more time than there are words for. Two bodies, Saturn and Dione, a massive anchor and a companion going around it. When two bodies like this exist in space, one very massive, one much less so, the smaller one orbiting the larger, the gravitational field they create together, as a pair, is not uniform. It is not simply Saturn's pull radiating outward in neat concentric rings and Dion's pull doing the same on a smaller scale beside it. The two fields interact, overlap, cancel each other in some places, and reinforce each other in others. And the result of that interaction is a landscape. Not a literal landscape, not one you could walk across, but a landscape in the mathematical sense, a surface of potential energy that has hills and valleys, ridges and hollows. Places where the pull from both directions happens to balance in a way that lets a third, very small body hold its position relative to the two larger ones without needing to do anything at all. Joseph Louis Lagrange worked this out in the 18th century, working through the mathematics of what is called the restricted three-body problem, what happens when you have a very massive body, a less massive body orbiting it, and then a third body so small that its own gravity doesn't meaningfully affect the other two. He found 5 points where the balance holds. 5 specific locations in the rotating frame of reference, where a small body, placed carefully, would stay in the same relative position as Dione goes around Saturn, riding along, keeping pace, neither falling inward toward Saturn nor drifting outward and falling behind. 3 of those 5 points are arranged along the line connecting Saturn to Dione and extending through it, one between them, one behind Dione on the far side from Saturn, and one on the opposite side of Saturn entirely, on the far side of the planet from Dione. These 3 points are what are called unstable equilibria, like the top of a hill. A marble placed precisely at the top of a hill will, in theory, stay there, but the slightest nudge sends it rolling, and once it rolls it does not come back. These 3 Lagrange points, L1, L2, and L3, as they are labelled, have that quality. Put something exactly there, and it might balance for a while. But the universe is never exactly still, and a very small nudge will send it drifting away with no force pulling it home. The James Webb Space Telescope, the great Golden Mirror Observatory that NASA launched in 2021 to peer back to the earliest moments of the universe, orbits the L2 point in the Sun-Earth system, the point about 1.5 million kilometers directly behind the Earth, as seen from the Sun. But Webb does not simply sit there in perfect stillness. It cannot. It fires its thrusters regularly, making small corrections, because L2 is unstable. Without those corrections, it would slowly drift away and never return. Webb is held at its perch not by the passive stability of the geometry, but by constant, careful, active maintenance. L4 and L5 are different. L4 and L5 are the 4th and 5th Lagrange points, and they are not on the line connecting Saturn to Dione at all. They are off to the sides. Specifically, L4 sits 60 degrees ahead of Dione along the shared orbital path, and L5 sits 60 degrees behind. And this geometry, this specific 60-degree offset, places each of those 2 points at the 3rd corner of what turns out to be an equilateral triangle. Saturn at one corner, Dione at another, L4 or L5 at the 3rd. An equilateral triangle in which all 3 sides are the same length and all 3 angles are exactly 60 degrees. There is something deeply satisfying about that, something that feels almost too clean to be real, as if the universe, left to its own devices, discovered an ancient theorem from Greek geometry and decided to build with it. And this triangular arrangement has a property that the 3 along the line points do not. It is stable, not just balanced, but actively stable. The kind of stability that belongs to the bottom of a valley rather than the top of a hill. Place a small body at L4 or L5, and if a small force nudges it sideways, the combined gravitational influence of Saturn and Dione does not push it further away from the balance point. It curves it back. It guides it, gently, in a way that keeps it circling around the point rather than escaping from it. The technical reason for this involves the way the Coriolis effect in the rotating reference frame interacts with the gravity gradient, forces that in combination create a restoring influence, a gentle but persistent pull toward the neighborhood of the balance point. But what matters for the picture is simpler than the mathematics. What matters is that L4 and L5 are the bottoms of valleys. Shallow valleys with gently sloping sides. And anything sitting in a shallow valley bottom, if nudged, will roll a little way up one side, slow down, and roll back. Not because anything is chasing it, but because the shape of the ground beneath it is always tipping it homeward. Polydeuces lives in that valley. Specifically, in the valley centered on L5, the trailing point, the 160 degrees behind Dione. But the stability of L4 and L5 is not unconditional. It does not work for any two bodies orbiting each other. It only works when the primary body, in this case Saturn, is sufficiently more massive than the secondary Dione, and the condition is precise. The mass ratio, the number you get when you divide the mass of the primary by the mass of the secondary, must exceed approximately 24.96 to 1. If the secondary is too heavy relative to the primary, if the two orbiting bodies are anything close to comparable in mass, then even the triangular points become unstable, the valley flattens out, and small bodies placed there eventually drift away for good. Saturn outweighs Dione by vastly more than that threshold. Dione is a moon of ice and rock, about 1,000 kilometers across, and Saturn is Saturn, the ringed giant, the second largest planet in the solar system. The mass ratio between them exceeds the required threshold so thoroughly that the question is not even close. The valley at L5 is deep by the standards of Trojan stability, its slopes well defined, its capacity to hold a wandering companion secure against any of the forces that are likely to act on a small body there. Polydeuces is not at risk of escaping. Not now, not at the current scale of its libration, not for any time scale that has meaning to a creature making sense of the solar system from a bed on Earth on a quiet night. The valley holds. But here is the thing about valleys, especially shallow ones. When a marble rolls into a shallow valley and begins oscillating back and forth, the distance it travels before stopping and returning, the amplitude of its oscillation depends on how far from the center it started and how fast it was moving when it first arrived. A marble dropped from a great height down the sloping wall of a shallow valley will roll far past the bottom, climb high up the other side, slow to a stop, and then roll all the way back, and then past the bottom again, and up the original side, and back, endlessly, as long as the valley provides no friction to drain away the energy. The marble's oscillation is wide, not because the valley is steep, but because the marble arrived with energy to spare. Polydeuces arrived with energy to spare. At some point in the history of this arrangement, perhaps when the system of Saturn's inner moons was still being assembled, perhaps as a result of some collision or gravitational nudge from another body, perhaps simply because the starting conditions happened to place it not quite at the exact center of its L5 valley, but somewhat to one side and moving, Polydeuces settled into its current libration with a wide amplitude rather than a narrow one. It was not placed precisely at the deepest point of the bowl and left there without motion. It was placed somewhere on the wall of the bowl, already moving, with enough energy to carry it far across the hollow before the gravitational geometry could slow it and turn it around. And because the hollow has no friction, because this is space, and there is nothing to slow the motion down, no air resistance, no rocky ground to drag against, nothing to leach away the energy of the oscillation. It has been rolling back and forth across that hollow ever since, at the same amplitude, with the same tireless patience, for longer than anything on Earth. This is part of what makes the size of Polydeuces' libration make sense once you think about it. But there is another part, and this part is about mass. Mass, in the context of oscillating systems, is what we mean when we talk about inertia. How difficult something is to push, how much force it takes to change its motion. A large, heavy object placed in a valley takes a great deal of force to set rolling, and once set rolling, its momentum carries it a certain distance before gravity can halt it and reverse it. A tiny, nearly massless object placed in the same valley, takes almost no force to start moving. The faintest perturbation will set it in motion, but once it is in motion, it has very little momentum to carry it forward, so one might expect it to stop and reverse quickly, tracing only a small oscillation. The key is what is doing the pushing in the first place. Polydeuces, at approximately 2.5 kilometers across, a body smaller than most cities, a body you could walk across in less than an hour, has a mass that is essentially negligible on the scale of the Saturn system. It exerts no meaningful gravitational influence on anything around it. Saturn does not feel it. Dione does not feel it. Helene does not feel it. But Dione and Helene and all the other moons of Saturn do exert gravitational influences on Polydeuces. Faint ones by the standards of the solar system. But faint is relative, and for a body with so little mass, even faint gravitational tugs are enough to produce measurable effects. Think of it this way. If you want to push a boulder across a field, you need a great deal of force, more than any ordinary gust of wind can provide. But if you want to push a feather across a field, even a modest gust will send it rolling and tumbling. Polydeuces is the feather. The gravitational influences of the moons around it, Dione ahead of it, Helene ahead of Dione, Tethys in its own separate orbit. All the others arranged in their patient rings around Saturn are the gusts. Not strong by astronomical standards, but strong enough, acting on something with so little inertia, to keep nudging it across the wide, shallow hollow of its L5 valley rather than letting it settle at the centre. This is the double explanation. Polydeuces librates widely because it arrived in its valley with energy already built in, placed off-centre by whatever initial conditions established this arrangement. And it remains in a wide libration, the wide arc sustained across billions of days, because it is so light that the ongoing faint nudges from its neighbours keep the motion alive rather than letting it decay. In a system with friction, the oscillation would gradually lose energy and the marble would spiral toward the centre of the bowl, coming to rest eventually at the exact balance point. But there is no friction, and the nudges keep coming, and so Polydeuces keeps rolling, 30 degrees to one side of the balance point, then slowing, then 30 degrees back, and through the centre, and 30 degrees to the other side, and slowing again, and back in that enormous 790-day breath that we have already named. And as it librates, as it rolls through this arc of 60 degrees total, 30 degrees on each side of the L5 point, something else changes too. Something you can see if you imagine watching from above. Polydeuces shares Dion's orbital track. Both of them are travelling the same great circle around Saturn, the same ring of space at a distance of about 377,400 kilometers from the planet's center. But they are not traveling side by side. They are separated along that track. Polydeuces is behind Dione, keeping a distance behind it that varies depending on where in the libration Polydeuces currently is. When Polydeuces is near the center of its oscillation, near the L5 point itself, it is roughly 60 degrees behind Dione along the shared orbit. When it has drifted to the leading edge of its libration arc, it has moved forward relative to L5, now perhaps 30 degrees behind the balance point, which means it is only about 30 degrees behind Dione. And when it has drifted to the trailing edge, it has moved backward relative to L5, sitting perhaps 30 degrees behind the balance point in the other direction, meaning it is now about 90 degrees behind Dione. 30 degrees behind on one side, 60 at the centre, 90 degrees behind on the other side. That is the full range of the angular distance between the two moons as seen from Saturn. And because both moons are travelling at roughly the same distance from Saturn, the actual physical separation between them, the straight-line gap of empty space you would have to cross to travel from one to the other, changes enormously as that angle changes. When Polydeuces is at its closest approach to L5 and only about 30 degrees behind Dione, the two moons are somewhere in the neighbourhood of 190,000 kilometres apart. That is still a long way. That is roughly half the distance from the Earth to the Moon. But by the standards of this dance, it is close. When Polydeuces has swung to the far end of its libration arc and is 90 degrees behind Dione, the gap between them grows to something well over 500,000 kilometres, more than the distance from Earth to the Moon and back. The same distance, the same two moons. But the gap between them breathing open and closed, over the course of each 790-day cycle, like the slow expansion and contraction of something alive. This is what libration looks like when you translate it into space. Not a tidy, small, contained oscillation around a point. A vast breathing of the distance between two moons, expanding over months from something you might loosely call near to something genuinely immense, then contracting again, then expanding, in a rhythm that goes on and on as long as the system holds together. Polydeuces and Dione do not just share an orbit, they share a pulse. A slow one, far slower than anything biological, measured not in seconds or minutes but in hundreds of days. But a pulse nonetheless. Now, there is a question that may be forming at the edges of the mind, the kind of question that surfaces when you have been listening for a while and something starts to feel unresolved. If Polydeuces' libration can be this wide 30 degrees to each side of the balance point, the distance to Dione swinging from 190,000 kilometres to over 500,000, could it swing wider still? Could it, given some additional nudge, drift even further from L5? And if it did, what would happen? Would it escape the valley entirely? The honest answer is, not easily, and not at its current energy. The valley is shallow, but it is real, and the current amplitude of Polydeuces' libration, while the largest known for any Trojan body, is still well within the bounds of the stable region. The slopes of the bowl, though gentle, are there, and they turn the marble back before it reaches the rim. Polydeuces would need a significantly larger perturbation, a close encounter with another moon, perhaps, or some unusual configuration of gravitational tugs from multiple bodies at once, to gain enough energy to push it over the edge of the stable region. The solar system is not a perfectly static thing, and over enormously long timescales these configurations do shift. But on any timescale that makes sense to hold in the mind, Polydeuces is bound. The valley holds it. But the question opens onto something worth exploring. Because there is another kind of orbit that some co-orbital bodies follow, bodies that orbit the same path around a planet as each other, and it is different in character from the libration Polydeuces traces. It is called a horseshoe orbit. And knowing about it makes the Trojan libration, the tadpole orbit that Polydeuces follows, come into sharper focus by contrast. In a horseshoe orbit, a body does not stay associated with just one Lagrange point. It drifts from one side all the way across the angular space between the two moons, approaches the other moon, gets slowed and deflected by its gravity before it can collide, then retreats all the way back around the other side of the orbit, approaches the first moon from the other direction, gets deflected again, and then makes the full crossing again. The path it traces, if you draw it in the rotating reference frame, the frame in which the reference moon appears to stand still, looks like a horseshoe. It loops around L4, crosses through the space behind the reference moon, loops around L5, and comes back. The body spends most of its time near the two Lagrange points, and very little time in the middle stretches, and crucially, what deflects it and turns it around at each end of the horseshoe is a close gravitational interaction with the reference moon itself. An approach close enough to exchange energy and momentum in a way that sends the smaller body retreating. At Saturn, there is a famous example of this kind of co-orbital motion. Janus and Epimetheus, two small moons that share the same orbital path around Saturn, perform a version of this exchange every 4 years. They are not Trojans. They are not at each other's Lagrange points. They follow a kind of mutual horseshoe, approaching each other periodically, swapping a little energy when they get close, and trading places, the one that was slightly closer to Saturn moving to a slightly farther orbit, and vice versa. Because orbits at different distances from Saturn travel at different speeds, the two moons then begin pulling apart again, the inner one slowly gaining on the outer one as the years go by, until after about 4 years they have come back together from the other direction and the exchange happens again. Janus and Epimetheus are often described as moons that swap orbits, because in a sense they do. They trade the inner and outer positions every 4 years, never quite catching up enough to collide, never quite escaping each other either. This is a genuinely different phenomenon from what Polydeuces does. They share a surface similarity. Both involve two bodies in the same orbital region. Both involve motion that carries one body toward and away from the other in a periodic rhythm. But the mechanism is entirely different. Janus and Epimetheus exchange gravitational energy directly with each other in those close approaches, and the exchange is large enough to reverse their relative drift entirely. Polydeuces does nothing of the kind. It is not engaged in any direct, close, energy-exchanging encounter with Dione. It is simply rolling gently back and forth in the stable gravitational hollow that Dione's presence creates 60 degrees behind it. Dione does not deflect Polydeuces at the ends of its swing the way Janus and Epimetheus deflect each other. The turning force comes not from proximity, but from the shape of the potential well itself, from the slow curving of the gravitational landscape that L5 represents. The shallow valley that always tips the marble homeward before it can reach the rim. The path Polydeuces traces in the technical vocabulary of orbital dynamics is called a tadpole orbit. If you draw it in the same rotating reference frame in which Dione appears to stand still, the path curves around the L5 point, looping out to one side and then the other, describing a shape that is narrow at one end and wider in its loop at the other. Like the body and tail of a tadpole, it stays always in the neighbourhood of that one Lagrange point. It does not cross to L4 on the other side, does not approach Dione closely, does not make the full horseshoe crossing. It is smaller, quieter, more contained, though by the measure of its amplitude, as we have said, it is the widest such tadpole in the known solar system. It is a large tadpole, but it is still a tadpole. There is a threshold, a particular amplitude at which the tadpole libration could, in principle, grow wide enough to become something else. If Polydeuces' swing grew dramatically larger, the loop of its path would approach the region around Dione more closely, and eventually the geometry would tip over into the horseshoe topology. The body would stop being a Trojan and start being an orbit crosser, swinging around both Lagrange points instead of one. Polydeuces is not near that threshold. Its libration is wide as tadpole librations go, but it is still firmly in tadpole territory. The possibility of that transition exists in the way that many possibilities exist in a dynamic system over infinite time. But it is not what is happening now. What is happening now is the gentler thing, the patient, repetitive, enormous amplitude rocking around one quiet point in space, out and back, out and back, the sway that has been going on since before the first ancestor of anything alive was anything alive. There is one more piece of this, one more element of the why, and it sits in the numbers. The stability of L4 and L5 depends, as we noted, on the mass ratio exceeding about 24.9, 6 to 1. And the depth and the shape of the potential well, how steep or shallow the valley walls are, how strongly a displaced body is guided back toward the balance point, also depends on the mass ratio and on the distance of the orbit. For Saturn and Dione, the valley is real, but it is not steep. The restoring force that guides Polydeuces homeward when it has drifted to the edge of its arc is not a sharp snap, not the way a rubber band snaps when released. It is a gradual, persistent, almost imperceptible lean, a slope so gentle that a body moving across it accumulates the corrective force slowly, over weeks and months. The arc turning by a tiny amount each day, until the direction of travel has curved all the way around and the body is drifting back toward center again. This is why the libration period is 790 days. Not because the orbit is slow in general, Dione and Polydeuces both complete a full lap around Saturn in less than 3 days. But because the curvature of the potential well is so slight that the restoring motion it induces takes years to accumulate into a full oscillation. You can think of it this way. Imagine a very long, very gentle slope, so gentle that you might walk across it for an hour before you noticed the ground was not quite flat. If you set a ball rolling on that slope, it would gather speed only slowly. It would travel a long distance before the slope had curved it enough to turn it back toward the center. The ball would be in no hurry. It would drift to one end of the slope gradually over a long time, and then drift back gradually over another long time. The shallowness of the slope is directly reflected in the slowness of the cycle. Polydeuces experiences a slope that is, by the scale of gravitational potential wells, extraordinarily gentle, and so its cycle is, by the scale of orbital dynamics, extraordinarily slow. 790 days for one complete out and back. More than 2 years, and within that vast, slow breath, the distance between Polydeuces and Dione expands from something resembling near to something genuinely far and back again, all of it at a pace that has nothing urgent about it, nothing sharp, nothing that would disturb the sleep of even the lightest sleeper. This is the physics of the why. The valley is real, but it is shallow. The stability is genuine, but it is patient. The restoring force exists, but it speaks softly, and it speaks over years rather than seconds. Every one of those properties, the shallowness, the patience, the softness of the pull, is itself a consequence of the mass ratio between Saturn and Dione, and of the distance of the shared orbit from Saturn's center, and of the equilateral triangle geometry that places L5 exactly where it is. It is not an accident that the libration feels like a slow rocking. It is what the mathematics predicts, and the mathematics is the shape of the physical reality, and the physical reality is a 2.6-kilometer speck of ice rolling back and forth in a hollow that takes 2 years to cross and another 2 years to cross back, held by nothing stronger than the geometry of a triangle and the patience of gravity working over time. And it is doing this right now. Somewhere in the outer solar system, in the cold and the dark beyond the asteroid belt, beyond Jupiter's vast influence, in the orbital neighborhood of the ringed planet. At this moment, as you listen, Polydeuces is somewhere along its arc. It might be near the center of its swing, close to the L5 balance point. The distance between it and Dione, somewhere around 300,000 kilometers. Or it might be near the trailing edge of its arc, the gap between it and Dione having opened to something over 500,000 kilometers. Or it might be closing back towards center, the distance contracting again day by day, the arc curving homeward under the patient influence of the gravitational geometry. There is no way to know from here exactly where in the 790-day breath it currently sits. But it is somewhere in the arc. It is always somewhere in the arc. It has been somewhere in the arc since long before any human eye was pointed at the sky. The 24th of October in 2004 was the day the Cassini imaging team, reviewing images the spacecraft had taken of the space around Dione, found it. A point of light in the wrong place, a speck that moved relative to the stars in the background in a way that was consistent with it orbiting Saturn. A speck that subsequent analysis placed near the trailing Lagrange point of Dione. For a while it had only a provisional designation, S2004 S5. The fifth new satellite of Saturn, found in 2004. A catalogue entry. A data point. Something to confirm, to track, to add to the growing list of small companions that Cassini was revealing one by one as it moved through the Saturn system, its cameras patient and tireless, surveying the space around moons and gaps and ring edges for the faint-moving specks that prior telescopes had been too far away or too limited to see. But even then, in those first images, the numbers were extraordinary. The libration amplitude, worked out from the orbital analysis, was larger than anything known for a Trojan companion. Tens of degrees, wider than any Jovian Trojan asteroid, wider than any other moon companion. Here, in the trailing region of a medium-sized moon around Saturn. The smallest object anyone had yet named in the system was performing the largest amplitude Trojan oscillation in the solar system. The tiniest body had the widest sway. And the reason for that, the reason a feather moves further in a wind than a stone, was itself already implicit in the number, already written into the physics, waiting for someone to read it. And someone did read it. Someone, several people, a team of patient analysts working through the orbital mechanics in the months and years that followed the discovery, read that number and understood what it meant. Not just as a measurement, not just as a data point to be filed and catalogued alongside the designation /2004 S5 and the approximate diameter of 2.6 kilometers and the orbital period borrowed from Dione. They understood what it meant in the larger context of everything humanity had ever found, wandering near a Lagrange point, anywhere in the solar system, around any planet, in any configuration of primary and secondary and small accompanying body. They understood it as a record, the largest libration amplitude of any known co-orbital body. Not by a small margin, not by a technicality. By the clear, generous measure of a thing that simply swings further than anything else of its kind that we have ever found. Think about what that means for a moment, if you are still awake enough to hold the thought. Jupiter has thousands of Trojan asteroids. Thousands, they cluster at the leading and trailing Lagrange points of Jupiter's enormous orbit around the Sun, and they have been known and studied for over a century. The first Jovian Trojan was discovered in 1906, and in the century and more since then, we have found and catalogued an enormous population of them, some quite large, some irregular, some ancient beyond easy reckoning, some carrying on their surfaces the dark organic chemistry of the early solar system. They are, by number and by the breadth of scientific attention paid to them, the best-known class of Trojan body in existence. And every one of them, every single one of those thousands of ancient companions riding Jupiter's Lagrange points, librates less than Polydeuces does. Every one of them stays closer to its assigned position, swings through a narrower arc, keeps a tighter rhythm around its balance point. The champion of the Trojan asteroids, the most restless of the thousands, does not wander as far as this 2.6-kilometer fleck of ice that Cassini found drifting behind a medium-sized moon of Saturn in the autumn of 2004. That is an extraordinary thing to sit with. The scale of it has a certain quiet comedy to it, if you are the sort of person who finds comedy in orbital mechanics, which, lying in the dark listening to the slow turn of a narration about a wandering moon, you may well be. Here is the picture: Jupiter, the largest planet in the solar system, nearly 11 times wider than Earth, containing more than twice the mass of all other planets combined, has escorted thousands of companion bodies around the Sun for billions of years, and the most restless of those companions, the one that wanders the widest, that rolls the farthest from its balance point before sliding back, still does not wander as far as a 2.6-kilometer piece of ice that nobody knew existed until a spacecraft found it drifting quietly behind one of Saturn's middle-sized moons. The smallest named moon of Saturn outswings Jupiter's entire retinue of ancient companions. The feather beats the boulder because the feather is light enough to be moved. That is the physics, translated into something you can hold. A marble dropped into a bowl will travel further along the bowl's curved wall if the marble is very light, because the same faint tug of gravity that would barely shift a heavy stone is enough to send the light thing rolling all the way to the other side. Polydeuces is the lightest marble. Its mass is almost nothing, a body 2.5 kilometers across, made mostly of ice, carries almost no inertia in the gravitational sense, and the bowl it sits in, the gentle potential hollow of the trailing Lagrange point of Dione, is wide and shallow rather than narrow and steep. Wide because Lagrange point stability operates over a broad region, not a pinpoint. Shallow because the forces involved are faint, the perturbations gentle. The gravitational gradient a long gradual slope rather than a cliff. A light marble in a wide, shallow bowl does not rattle quickly back and forth in tight little arcs. It rolls out slowly to one side, all the way to where the rim begins to curve it back, and then slides back through the center and climbs the other side and pauses again and returns. Wide, slow, unhurried, a sway rather than a rattle. And because there is nothing to slow it down, no friction, no atmosphere, no ocean of resistance, it keeps going. The same sway, repeated, out and back, over a period of 790 days, more than 2 years, for a single passage. The record is not an accident. The record is a consequence. A more massive object, placed at that same Lagrange point, would sit closer to the center, would feel every faint perturbation less, would swing a shorter arc, and a steeper potential well would snap things back more sharply, would constrain the motion to a narrower band. Polydeuces has the record because it is small, and because the well it lives in is just the right depth, or the right shallowness, to let it wander 30 degrees to either side of its balance point without ever quite escaping. Just wide enough to hold the title. Not so wide that it loses its way. It never loses its way. That is the part worth holding on to. in the dark, when the thought of endless wandering starts to edge toward something unsteady. Polydeuces drifts. Polydeuces has drifted for as long as it has occupied that region of Saturn's orbital system, which may be a very long time indeed, long enough that the exact history of how it came to be there has been absorbed into the silence of deep time and cannot now be easily read. But it has never left. It wanders to the edge of what the Lagrange point will allow, and it slides back. It wanders again. It slides back again. The geometry of the situation, the simple fact that it was born into a stable configuration, means that the wandering and the returning are the same motion. You cannot have one without the other. The drift out is already the beginning of the drift back. There is no moment of danger, no near escape, no edge from which it might topple off into a different trajectory. There is only the sway. Endless, patient, safe. This is, if you are willing to receive it as such, a kind of reassurance that the universe does not often offer so directly. Now, the easiest way to understand why the sway is safe, why it returns reliably every time, is to compare it to something closer to home, something that a great many people in the United States have heard of in recent years, because it carries a telescope that has been sending back images of the universe at depths of distance and time that still seem almost impossible to take in. The James Webb Space Telescope. Launched on the 25th of December in 2021, it traveled to a point in space called the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth in the direction directly away from the Sun. And it sits there, doing its extraordinary work, looking out into the ancient universe from a stable, cold, unobstructed vantage. But here is what is not often mentioned when people talk about that telescope's parking spot. The Sun-Earth L2 is not naturally stable. It is a Lagrange point, yes, but it is one of the three collinear points, L1, L2, and L3. That sit along the line connecting the two main bodies, and those 3 points are not like L4 and L5. The triangular points, the ones 60 degrees ahead and behind, are the naturally stable ones. The collinear points are what is sometimes called saddle points in the potential energy landscape, stable in some directions, unstable in others. A spacecraft placed at L2 will drift away from it over time unless it fires its thrusters periodically to correct its position. The James Webb Space Telescope carries propellant for exactly this purpose. Its station keeps. It pushes back against the tendency to drift actively, at intervals, using the fuel it brought with it from Earth. When that fuel runs out, and it is expected to last for decades, the telescope was launched with margins built in. There will be no more station keeping, and the telescope will drift away from L2. Polydeuces has no thrusters. Polydeuces carries no fuel. No one is watching a telemetry readout and calculating a correction burn. And yet, it keeps its place. Not exactly, not in a pinpoint way, but in the patient, oscillating, always returning way of something held by a stable gravitational embrace. The L5 point behind Dione is genuinely stable in the way that the triangular Lagrange points always are when the mass ratio of the two main bodies is large enough, and for Saturn and Dione the ratio is more than large enough. Saturn outweighs Dione by an enormous margin, far beyond the threshold the mathematics requires for L4 and L5 to close around a small body and hold it. So Polydeuces needs no engine, it needs no correction, it just sways, and the same physics that lets it wander also guarantees its return. The stability is built into the geometry of the situation, into the angles, into the particular shape of the gravitational landscape that Saturn and Dione together create. The James Webb Telescope holds its place through engineering, through propellant, through the deliberate effort of mission controllers who calculate every burn. Polydeuces holds its place through nothing but the quiet mathematics of orbital mechanics, through the shape of space around it, through the accident of being in the right configuration in the right solar system. One of these is a magnificent human achievement. The other is simply the universe being what it is. And Cassini found it. That is worth saying slowly and holding for a moment. Cassini was launched on the 15th of October 1997. That was more than a quarter of a century ago now. The spacecraft left Earth on a trajectory that would take it not directly to Saturn, but on a long curving path that would borrow gravity from Venus twice, then from Earth once, then from Jupiter. Using each flyby to accelerate a little more, to store up the velocity it would need to cross the cold distance to the outer solar system, and then decelerate enough to be captured by Saturn's gravity rather than sailing past it. That kind of trajectory, that long, patient accumulation of borrowed speed, is itself a kind of orbital poetry. A spacecraft that cannot carry enough fuel to push itself all the way to Saturn under its own power, so instead it falls toward Venus, swings around, gains speed, falls toward Venus again, swings again, comes back to Earth, and swings around home, gaining more, then arcs out to Jupiter for one more gravity assist before the long, quiet coast to Saturn. 7 years of travel, 7 years in which the spacecraft crossed the solar system on a curving path no human being could walk or drive, falling always toward something larger, borrowing a little momentum from each encounter and storing it for the next. It arrived at Saturn on the 1st of July 2004. It crossed the ring plane, passed through a gap between two rings, fired its main engine for the 96-minute burn that would slow it enough to be captured rather than slung onward, and entered orbit. And almost immediately it began to find things. The Saturn system, seen up close for the first time with instruments of that precision and sensitivity, turned out to be richer than anyone had fully anticipated. Small moons materialized in images where prior observations had shown only empty space. Gaps in the rings resolved into structures with their own complexity. The moons that were already known grew in detail and strangeness with every flyby, and in the images taken of the space around Dione, in the data reviewed by the team that autumn, there was S2004 S5. A point of light in the wrong place. Polydeuces, Cassini did not stop after that. It kept going, kept orbiting, kept discovering and measuring and imaging for 13 years. 13 years in orbit around Saturn, crossing the ring plane again and again, diving close to moons, sampling the atmosphere of Titan, detecting the plumes of Enceladus, watching the storms that move through Saturn's upper atmosphere in vast golden bands. It operated for far longer than its primary mission had specified. And then, in the spring of 2017, the mission controllers made a decision that was both practical and, depending on how you hold it, deeply moving. The spacecraft was running low on propellant. Without propellant, it could no longer be steered, could no longer be kept away from moons whose potential for harboring life made accidental contamination a concern. So they chose to end the mission deliberately. They put Cassini on a new orbital path, a series of 22 close passes between Saturn's rings and Saturn itself, the sequence they called the grand finale. And then, on the 15th of September 2017, they aimed it at the planet. It entered Saturn's atmosphere at dawn on the sunlit side above the northern hemisphere. It was travelling at tens of kilometers per second. The atmosphere resisted. The spacecraft tried to hold attitude, tried to keep its antenna pointed at Earth so that the data could flow back as long as possible. The last measurements of the last moments, and then it tumbled, and the signal broke apart, and Cassini became part of Saturn. Molecules that had been manufactured on Earth, that had travelled through the inner solar system and out past the asteroid belt and through the outer dark to Saturn, became part of the planet they had spent 13 years studying. A small, intimate ending, a disappearance into the thing itself. It had found Polydeuces. Among thousands of other things, it had found this 2.6-kilometre wanderer and revealed its extraordinary sway. And then it was gone, folded into the clouds of the planet it had come to understand. The wanderer it found goes on wandering. The record it revealed goes on being set, quietly, without witnesses. In the trailing region of Dione's orbit, 790 days per cycle, out and back, and out and back. There is something worth saying about the name. Polydeuces is the Greek name for the figure the Romans called Pollux, and Pollux had a brother. The brother was Castor. Together they were the Dioscuri, the twin sons of Leda, and their story as it has come down through the long centuries is, at its heart, a story about companionship and an orbit that could not be broken. They were, in most versions of the myth, only half-brothers, Polydeuces the son of Zeus, immortal, Castor the son of a mortal man, and therefore mortal himself. When Castor was killed, Polydeuces could not bear the separation. He was immortal, and his brother was not, and he petitioned his divine father for a resolution that the normal ordering of things did not permit. What was granted, in the telling, was a kind of shared alternation. The two brothers spent their time between the world of the living and the world of the dead in turns, neither fully in one place nor the other, always in a kind of motion between two states, together and apart and together, over and over, in something very much like a slow oscillation between two conditions that neither could permanently occupy. This is a myth, and it should be received as one, not as science, not as an explanation of anything physical, but as a story that people told about two brothers and the persistence of connection across an impossible gap. And yet the moon named for one of those brothers does something that the myth describes in its own language. Polydeuces does not sit at its assigned point. It moves away from it, pauses, returns, moves away again. It is always between two places, always in a kind of passage, always returning to the companion it orbits near, and then drifting again and returning again. Whether the people who named it had this resonance in mind, or whether they simply reached for a twin's name because Helene was already across the way on the other side of Dione, is not recorded. Perhaps both. The names of solar system bodies are chosen by committees and approved by the International Astronomical Union and arrive through a process that is practical and methodical and not especially given to poetry. But the resonance, once noticed, is hard to unnotice. A moon named for one half of an inseparable pair, a moon that circles endlessly around the midpoint between its own place and somewhere else, that is always in motion between two states, never quite settled, never quite gone. In the old myths, the Dioscuri were also the patrons of sailors. They were said to appear as calming lights to those lost at sea in storms. The phenomenon we now understand as St. Elmo's fire, the glow that sometimes appears at the tips of masts in certain electrical conditions. Sailors who saw those lights in the dark believed they were being watched over, being guided toward safe harbour. The brothers who could not remain fixed in one place were, in that tradition, precisely the ones you turned to when you yourself were lost and needed the assurance of a return. The moon named for one of them keeps its own watch, out past the ring system, in the trailing shadow of Dione, rolling its long, slow arc through the hollow of the Lagrange point and back again. It does not know it is watched. It is not watching. It is simply doing what the physics of the situation makes inevitable, which is to sway and sway and sway, without urgency, without end. And now consider one more time the whole arrangement. Not in technical detail, you have had the detail, and it is settled in you now, or it is drifting with you into sleep, which is also fine, but in the broadest possible view. Saturn sits at the centre of this, 9.5 times farther from the Sun than Earth is, a world so large that 1,000 Earths could fit inside it, ringed by a system of ice and dust that stretches out for hundreds of thousands of kilometres, and yet is in some places only tens of metres thick. Around Saturn, at various distances, at various periods, orbit more than 100 moons. Some of them are large enough to be round, pulled by their own gravity into spheres. Some of them are irregular, shaped by the accumulated impacts of billions of years in a crowded system.
And some of them, the small ones, the quiet ones, have found particular places to keep, not just anywhere in the orbital space around Saturn, but specific positions relative to their larger neighbours, specific angles, specific distances, specific configurations that the mathematics of the three-body problem identified centuries ago as places where things can remain. 60 degrees ahead of Dione, Helene keeps its place, tumbling gently on its own axis, brighter than Polydeuces, larger, a little more visible in the images Cassini took as it passed nearby. And 60 degrees behind, in the trailing region, in the gentle hollow of L5, the little wanderer goes on doing its extraordinary, quiet, record-setting thing. 2 companions, 1 moon between them, a system that has been exactly this way for longer than human memory extends, longer than human civilization, longer than the genus Homo has existed, longer, perhaps, than the Earth's oceans have been the shape they are now. The arrangement does not hurry, it does not announce itself, it simply continues. You are lying in the dark, and the universe is doing this right now. At this moment, as you breathe and the room settles around you, Polydeuces is somewhere in its 790-day arc. It might be near the midpoint of its swing, crossing closest to Dione's exact trailing position, on its way from one extreme to the other. It might be at the far edge of its wandering, about to pause and begin the long slide back. It might be anywhere along that gradual curve, moving at its slow and patient pace, covering the distance that a body in a nearly circular orbit covers, which is to say, a distance we cannot walk, cannot drive, cannot easily imagine. And yet, in the context of the Saturn system, in the context of the distance from Saturn to the Sun, in the context of the distance between stars, a short and gentle commute. A local errand, a body that never goes far and always comes home. There is no danger in what it does. There is no drama in the sense of risk or peril. Other systems in the universe perform their motions at violent energies. Stars collide. Black holes merge in collisions that send ripples through the fabric of space itself. Gas clouds collapse into explosions so bright that a single one can briefly outshine an entire galaxy. The universe, on its larger scales, is not calm. But here, in this particular corner of one ordinary solar system, one tiny moon goes back and forth in its shallow valley, with an amplitude that holds a record only because it is the most extreme version of a fundamentally gentle phenomenon.
It is not the most energetic object in the universe, it is the most restless, in one very specific and very patient sense, of all the Trojan companions we know. And restless is the wrong word even. It suggests anxiety, suggests urgency. What Polydeuces does is not restless. It is rhythmic. It is tidal. It is the natural motion of something light held gently in a bowl that tilts just enough to keep it moving without ever letting it go. If you have been in the ocean, floating on your back in calm water, you have felt something related. Not the physics. The physics is different. The mechanism is different. But the feeling of being rocked by something vast and unhurried and thoroughly indifferent to you. A swell that comes from somewhere far away, that lifts you slightly and lowers you again and lifts you again, with a period that has nothing to do with your comfort or your schedule or your intentions. You float in it. You can resist it if you tense your body and try to hold a fixed position, but if you release, if you let the tension go and allow your weight to settle into the water, the swell just carries you, up and down, again and again. You are not in danger, you are simply being moved. Polydeuces is being moved. It has been being moved for a very long time, and it will be moved for a very long time more. And if you let your own weight settle into the thing you are lying on, if you allow the tension that keeps you in one position to ease just slightly, you might find that you are also, in some small and quiet way, being rocked. The bed that holds you is not in space, it is on a planet. And that planet is turning, and the turning is so slow and so steady that you cannot feel it unless you watch the stars. But there is a rhythm even here, in the rise and fall of your own breathing, in the way the body, when it lets go, finds a slower tempo. In and out, again. The same motion, at a different scale, with different mechanisms, but something similar in the structure of it. Something that keeps going without effort. Something that, if you stop fighting it, carries you. The Saturn system is approximately 1.4 billion kilometers from Earth right now, give or take, depending on where the two planets are in their orbits around the Sun. That number is too large to picture, but there is a wandering moon out there in that distance, 2.6 kilometers across, holding a record it did not apply for, keeping a place it rarely sits in, doing the largest known Trojan libration in the solar system, without engines, without fuel, without intention, without anything except the patient geometry of three bodies and the slow, shallow valley that geometry creates between them. It drifts. It always slides back. It drifts again. If you are listening from somewhere on Earth tonight, and I would be genuinely glad to know where that is, whether you are in a city where the lights have mostly gone out and the room is getting quieter, or in a place where you can hear something outside, wind or rain, or the sounds that a house makes when it settles, leave a word in the comments. Even just your city or the country or only what time it is where you are. There are listeners in places I haven't imagined, and knowing the shape of where this reaches is one of the things that makes this kind of work feel like something more than a voice traveling into an empty room. You don't have to, but the offer stands. And if you are new here, and this slow, unhurried kind of narration is the thing you have been looking for, there are more of these waiting whenever you want them. Other mysteries, other orbits, other questions that the universe holds open and the physics holds gently without resolving into anything sharp or alarming. They will be here. You do not have to find them tonight. Tonight, let the 790-day breath of a small moon be the last thing the thinking part of you holds before the thinking part of you releases its grip. Out to one side, pause. Back through the middle, the other side, pause. Back again. The Lagrange point waiting at the center of the arc, as it has always waited, as it will wait until the Saturn system has changed into something we would not recognize from here. The equipment is all turned off now. The thrusters that keep the telescopes pointed are either firing or quiet, depending on the telescope, depending on the orbit, depending on the kind of stability the situation provides. The orbital mechanics proceed without anyone watching them. The 2.6-kilometer fleck of ice is somewhere in its arc, moving along the shared orbital track of Dione at the same steady pace it has always moved, drifting away from its balance point at a rate too slow to be urgent, too steady to be alarming, too regular to be anything other than what it is. A natural oscillation in a stable system, the solar system doing what it does when things are going well, which is to keep everything moving in the same patterns, on and on, past the edge of what we can call history. You have done enough for one night. Whatever you were carrying when you pressed play, whatever the day left in your muscles or behind your eyes or somewhere in the middle of your chest, you do not have to carry it any further tonight. The orbit does not need your help. The moon will drift without you. The 790 days will turn whether you are watching or not, whether you are awake or not, whether the channel that brought you here exists 10 years from now or not. Put it down. All of it. The Saturn system is a long way away, and it is very old, and it will be here, doing this, for a long time after any particular night is over. Good night from up here in orbit. I'll keep watch while you drift.